Hey guys, welcome to another video. Today's learning objective is to round numbers and measures to an appropriate degree of accuracy, e.g. to a specified number of decimal places or significant figures, using equality notation to specify simple error intervals due to truncation or rounding. As usual, feel free to skip to any part of the video if you timestamps are here. So yeah, let's get into it. Before I break down the learning objective, there's some prerequisite knowledge that you do need to know. So for example, you need to know, quite importantly, what inequality notation is. So we covered this out of camera, way back when. I think it was lesson 1. So, just a quick reminder, do you remember what this sign means, for example? If you could do that, you probably remember what inequality notation is. As a hint, maybe the crocodile teeth will help bring back some memories. But yeah. Okay, so let's break down the learning objective. There's two things we need to consider here. What kind of rounding numbers are, and why we round numbers, and appropriate degrees of accuracy. Those are the two key concepts here. Now first, let's talk about what rounding numbers is. So say let's say a piece of string. This is my piece of string, and I want to measure it with a ruler. So I get my ruler out, and I want to say it's like 14 centimeters, for example. But is it going to be exactly 14 centimeters? Or is it going to be perhaps, maybe 14.01 centimeters or 13.99 centimeters? And the thing is, in real life, we never have completely accurate and whole numbers. We'll never have a piece of string that's exactly 14 centimeters and not 14.000001 centimeters. So because of that, what we do in real life is that we round things to certain degrees of accuracy. So if we have, say, this piece of string, we can say it's 14 centimeters. Say it's 14.5 centimeters. Say it's 14.5 centimeters to 1 dp, 1 decimal place. And we write this in brackets here to say it's this degree of accuracy. And I've started talking about what appropriate degrees of accuracy are. Well, what are degrees of accuracy then? It's almost saying, how many numbers am I giving you by telling you how accurate it is? So almost if I say it's 14.555, for example, that's more accurate than that because it's telling me more numbers. Okay, so there's two different ways we measure degrees of accuracy. Or we might have something like, say, 13.95. Again, that's 2 dp. But let's compare this to, say, for example, 1395.0. So we're not even 0.0, 139. Well, now this is 0 dp, right? But in a way, isn't this almost the same accuracy as this? So say this was in, say, meters. Well, this is now in centimeters, and that's telling us the same thing. But the only difference is this power of 10. This is 100 times larger than this. But in a way, it's giving us the same information, and it's almost as accurate. And so this is why we could have something called significant figures, where we basically count the numbers of digits that aren't zeros. So for example, this is correct. This is 4 significant figures. This is 1, 2, 3, 4. So we can write this 1395 to 4 SF. And this is also 4 significant figures, right? So instead of counting the number of decimal places, we're just counting the number of total number of digits there are. But there's a thing we do need to note here. For example, if it was 13950000, this isn't giving us any more. These zeros don't give us that much more information, right? In terms of accuracy, they're just telling us the number is, say, 10,000 times larger than 1395. And as such, it's basically as accurate. So this is also 4 SF as this. So when it comes to significant figures, we just ignore the trailing zeros like this, the trailing zeros here. And then if it was something like, say, 0.0000000, sorry, let me go back to the black pen, 1395, well, we ignore these as well because they don't give us information in terms of how accurate it is. It just tells us something about the magnitude, and those are 2 different things. So that's 4 SF. But don't get sometimes students do get confused in terms of these significant figures. So if it was something like 130500, this 0 does actually give us information because it tells us that the the thousandths place is 0. So what you do is you ignore the trailing zeros, but not if there's, say, a 0 in the middle here. So this is still 4 degrees of accuracy. 4 significant figures. So yeah, that's a crucial thing to watch out for. Okay, now let's talk about rounding, how we round and how we truncate as well, these two things here. Okay, well, what is rounding? So say if we have a number like 13.75 and we want to round it to 1 decimal place. Well, what we do is we say, okay, 13.75 is closer to 13.8 than it is to 13.7. So when we round, we can round up to 13.8. But so the rule here is, right, if we want to round to, say, this place here, right, we look at the digit next to it, and if it's greater than or equal to 5, then we increase this number. But if it's less than or equal to 4, then we move it, and then we leave this number alone. So if, say, for example, if we have the numbers 14.7 and, I don't know, 12.2. Just take a moment to pause and think the video how we would, sorry, no, that's 7.5 and 7.2. Okay, so actually make that 7.6. Okay, take a moment to pause the video and see how we'd kind of round this to 1 decimal place. Well, okay, let's consider this one. It's 14.76, so that means this number is greater than 5, and we want to round to this one, right? So if it's greater than 5, we can increase this number, so we get 14.8. And we can write 1 dp to signify we're rounding to 1 decimal place. Again, we're rounding to 1 decimal place here, so this is the one we want to round to. So we look at this. This is this one. It's less than 4, less than or equal to 4. So we keep the 2 there. So 12.2, and we don't change it. So to 1 dp. Okay. Now, what's truncation versus rounding? So say if we had something like a number like 14.76543, and we want to truncate to 1 decimal place, what we do is effectively just get a pair of scissors out, and we go to 1 decimal place, and we ignore everything after that. And you can see how, even though if we were to round, we'd go to 14.8, but with truncation, we just stay at 14.7 because we just clip off anything afterwards. So you can write, truncated to 1 dp. To 1 dp. So that's the difference between truncation and rounding. Okay, so now we've got a question like this. Round 4.8, well, I'm not going to read that out, to 3 decimal places. So what I'll do is I'll write out, that's how I approach the question, 408.59578. I'll count to 3 dp, so 1, 2, 3. Get maybe a different color pen out and say, okay, so this is the number we need to consider when we round. So actually give the video a pause and see how you'd round it. So we know, these numbers here will stay the same, but this is greater than greater than or equal to 5, right? So we'll increase this number to 6, and there we go. That's 3 dp. That's all there is to it. And now there's another concept we need to consider, which is error intervals. So error intervals effectively come about because of the fact is, when we round, we say, for example, if a number is like this number, 43.2, well, we've rounded it to 1 dp, right? Well, that means the original number could have been anything from 43.25 to 43.15, right? And because it could have been any number like this, there's an error involved in this. So that's the error interval. So it says, the question is, the length of a piece of string is n, piece of string n, rounded to 1 decimal place is 43.2. Write down the error interval for the length of n. So we can say n could have been anything up to 43.25, or anything as small as 43.15. And so when we round it to 1 dp, n will then be 43.2, and this is why there's an error there. Okay, let's consider B. The length of a piece of string n is truncated to one decimal place. The length of a piece of string n truncated to one decimal place is 43.2. Write down the error interval for the length of n. Well, when we truncate 43.2, there could have been any digits here, right? Because we just chop off the kind of rest here. So, for example, it could have been, say, 43.2, 945, or it could have equally been 43.20001. And since we just cut off everything after 43.2, 43.2 has to be it's effectively less than 43. N could have been anything up to 43.3, but it has to be greater than 43.2, because, say for example, if it was 43.1999, while we would round this to 43.2, we'd round this to 43.2, but to truncate, we'd end up with 43.1. So it's crucial that we kind of remember the difference between truncation and rounding. So I hope that video made sense. We covered, different kind of how to round, how to truncate, what degrees of accuracy are, and a lot of the time, just kind of students get a bit confused, and kind of significant figures is a hard concept to wrap your head around. But it just doing more and more practice, it should eventually, hopefully, make more sense and become a bit more second nature. So see you guys in the next video.